Hi guys, and welcome to another video. Today we're going to be looking at analytical geometry and finding the angle between two lines using the angle of inclination. The question that we're going to be looking at is from the KZN March 2018 paper, and it reads as follows. In the diagram, P, Q, and R are the vertices of a triangle. PQ is produced to cut the x-axis at S, PR cuts the x-axis at T, and QR cuts the x-axis at A. Let's go read the first question. It says, calculate theta, the angle of inclination of the line PS. So if you look very carefully, we are focusing on the following line, which is PQS, and we want to find the angle of inclination. So if you look very carefully, the angle of inclination is the angle here, which is theta. And the definition of angle of inclination is that it's the angle that is made with the positive x-axis and moves in an anti-clockwise direction. So we can see that theta is an acute angle. So there are two formulas that we need to know when it comes to finding the angle of inclination. Remember that the gradient formula is m equals to y2 minus y1 all over x2 minus x1, and that's our gradient formula. Also, we can find gradient by saying m is equal to tan of theta. So if you're given the angle of inclination, you can find the gradient of the line. Now we are given two coordinates on the line, therefore we can find its gradient. We've got P and Q. So let's call this x2, y2, and we'll call that x1, y1. Let's substitute accordingly into our formula. 7 minus 4 all over x2 minus x1 will be 3 minus 3. So we have 7 minus 4 all over 3 minus, and in brackets, minus 3. That's equal to half. So therefore, the gradient of PQS is equal to half. Therefore, we can now say that theta is equal to tan inverse of half, using m equals to tan of theta. Remember, therefore, theta will equals to tan inverse of m. So let's now put that into our calculator. So now we'll say shift tan of half equals to 26.57 degrees if we round off. So now we got the answer, 26.57 degrees. Now let's look at the next question. Calculate the size of RQS, and this is the focus of today's lesson. Calculate the size of RQS. So let's look at RQS. RQS is following angle. So RQS is a part of this, so therefore it will be the angle in between here. So the angle between two lines using angle of inclination, which is the title of today's video lesson. So if we're going to find that particular angle there, remember now that we need to find this angle of inclination here. All right, and we're going to call this angle of inclination alpha. So if you look at it very carefully, for exterior angle of a triangle, you can see the formation of a triangle here. Remember, the exterior angle is equal to the sum of the interior opposite angles. Therefore, we can now conclude that RQS must equal to that angle alpha, which is going to be an obtuse angle, minus theta, which is an acute angle, and that is exterior angle of triangle. So what's left for us to do now is to just find alpha, the angle of inclination of QR. So let's do that. We have two coordinates here, and let's use those two coordinates now. So let's label it accordingly. So I like to call my top coordinate x2 and y2, and the bottom one, I'm going to call it x1 and y1. So once again, I'm going to use my gradient formula to find the gradient of QR, and therefore, which will enable me to find alpha. So let's go and do that. So 4.2.2. So let's write down the gradient formula once again. Y2 minus y1 all over x2 minus x1 equals 2. So I'm finding now the gradient of QR. That's QR. So y2, 4 minus 6. So that'll be 4 minus 6 all over. X2 minus x1 will be minus 3 minus 1. So that's minus 3 minus 1 equals 2. And let's put that in our calculator. So we got 4 minus, and in brackets, minus 6 all over minus 3 minus 1 equals 2. Minus 5 over 2. Minus 5 over 2. So therefore, the gradient of QR is equal to minus 5 over 2. Now let's find the angle of inclination of this particular line QR. Now we want to find alpha. Now don't forget that this line slopes in a direction where we have a negative gradient. Now this is how we deal with a negative gradient when finding the angle of inclination. Now watch very carefully. Alpha equals to tan inverse of minus 5 over 2. And we're going to add 180 degrees because remember, we are going to get an obtuse angle. So the process is a very simple one. If you have a negative gradient, all you do is substitute negative gradient into your formula, tan inverse of your gradient, and you add 180 degrees. Okay? When you have a positive gradient, you don't do that. All right? Because you're going to get an acute angle as an answer. So let's put that in our calculator. So now, as you can see, I'm going to say shift tan minus 5 over 2 and plus 180 degrees. And you will see here that we're going to get an obtuse angle, which is 111.80 degrees. Rounded off to 2 decimal places. Now remember what we established at the beginning of this question. RQS is going to equal to alpha minus theta, exterior angle of triangle. So let's write that down again. So we'll say RQS is equal to alpha minus theta, exterior angle of triangle, which is now going to equal to 111.80 degrees minus 26.57 degrees, 26.57 degrees. And let's put that into our calculator. So we already have 111.80 degrees there. So we're just going to say minus 26.57 degrees, 85.23 degrees, 85.23 degrees. So therefore, we can conclude that the angle RQS is equal to 85.23 degrees. Learners, I hope that this video lesson has helped you. If it has helped you, share it as much as possible. Don't forget to subscribe to my YouTube channel, JL Maths. Also like my Facebook page, Justin Lazarus Mathematics. And you can also check out my website, which is jlmaths.com. And I'll catch you in the next video.